So in this afternoon, we continue to study lecture 3, and then we continue to study lecture 4, part 1. Yeah. So in the morning, we discuss about the relationship between IF and IA, right? IF is field current, and IA mean phase current of the stator winding. Okay, so yeah, so we have the relationship between IF and IA, yeah, following by the V curve. So this one is BF equal to 0, and here we can get the V curve like this. Okay, so remember that this is lagging and this one is leading, right? Yeah. So if IF increase and IA decrease, so that means we have lagging come to unity, come to unity power factor right here. Yeah. Because lagging, so the synchronous motor will consume P and Q. Okay, that means we have B plus JQ. Okay, so for here, yeah, we have consume Q. That means the positive. Okay, so and then uh, from here for leading, so if IF in read, that means IA in read. So from here to here, okay, yeah, IF in read, IA in read because it is leading case. Okay, yeah. So for synchronous motors, they consume B but reject Q. That means now we have uh, reject reject Q to the system, to the grid, or to the system. Okay, so that means you get a minus Q, minus Q. Yeah. Or we can say that in case of leading case, leading the power factor Q E rejected into the grid. Okay, so here, for example, we have the grid. Okay, and now we have a synchronous motor, right? Yeah. So if we have lagging, so synchronous motor will consume B and Q. This is lagging. Okay. So for leading, yeah. So the synchronous motor will consume B, but reject Q. That means Q will come back to the power system. Okay. So you get minus Q. This is for leading. Okay, so if we have unity, if we have unity, so if we have unity, we only have B, we have no Q, no Q because power factor is 1, unity. Yeah, unity. So power factor is what does mean Q is 0, so we only have B. I just consume B. Okay, yeah. Or you can say if we have B plus JQ, okay, that means SM operate operate at under excited, okay, under excited system, under excited system. Okay, so if they consume B and they reject Q, that means SM operate at over excited system. Okay, remember that for over excitation, the synchronous motor will reject Q, will inject Q, okay, back to the power system. Yeah, okay. So continue. For example, here we have we have example 3. Okay, how many uh, synchronous motor we have? We have one. Okay, yeah, we have one. Look here, this is synchronous. This is synchronous. Yeah, this is synchronous. This is synchronous, and this is induction motor. Okay, for induction motor, they always consume B and Q. Okay, consume the B and Q. You know, if we observe the arrow comes from the power system to the motors. Okay, but this one is synchronous motor, so maybe they is consume Q3 or reject Q3. We don't know. We need to read example 3. We have this infinite bus operating at 480 volt. Okay, so load 1 they consumes, you know, this is lagging. Okay, lagging, so that means they consume B1 and Q1. Okay, so this is 100, right? 100 plus J. How about Q1? Okay, so we have cosine, right? We have, yeah, we have cosine phi 1 e 0.78, so we can get a sine phi 1, right? Then you can guess 0.625, so you can get Q1, right? Q1, Q1. Or you can calculate tan, right? Because tan phi 1 is, right? Tan well, tan phi 1 is a Q over B. Okay, so with we have tan phi is 0.8 times 100, so you get 80, right? Nearly 80. Okay, so this is S1, so the unit is kVA. Yeah, and similarly we have lot 2. Okay, this is lagging, so we have B2 plus JQ2. How about lot 3? Okay, they consumes 150 kilowatt. So if the synchronous motors is adjusted to operate at 0.85 power factor lagging, okay, so that means we have B3 plus JQ3. Okay, what's the transmission line current in this system? Okay, so question B, you know, now synchronous motors is operated at 0.85 power factor, but lagging, so we have B3 minus JQ3. Okay, so what's the line current? Okay, And we also calculate the power loss in the transmission line here. Okay, so this is the ideas. So we have the answers. Okay, so this is lagging, this is lagging, and if the power factor here is lagging, so we have B total, right? B total is B1 plus B2 plus B3. Okay, and Q total is Q1 plus Q2 plus Q3, because this is lagging. So all of them consumes B and Q, right? Okay, so you get how many? This is 100, 200, and 150. So you get 450 kilowatt. Okay, yeah. And for Q, yeah, of course we need to calculate Q. So for Q1, yeah, Q1 we get 82. Sorry, 80.2, and Q2 you get 150, and for Q3 you get 93. So after that you can get a Q total, this one plus this one plus this one, and you can get Q total is 323.2 kVAR. Okay, yeah. And this is Q total, and the B total you get how many? 450 kilowatt. Yeah, kilowatt. So after that you can get the equivalent power factors, or we can get the phi theta total. So cosine theta total is cosine of tan to the power of -1 Q over B. This is Q, this is B. So you get the theta, right? We have cosine theta total is what? Is okay. So maybe we calculate tan theta. Tan theta total is Q total over B total, and Q total is 323 over 450. Okay. So we can get 0.718. So you can get theta. Okay. Theta is 35.7 degree. So you have cosine theta. That means cosine of 35.7. And then you can get the answers. So we can get the power factor is 0.8122. Okay, here. Yeah, this is lagging. This is lagging. Yeah. So now we have cosine theta total, right? We have B total. Okay, so we apply the formula, you can get current, because IL is BL or B total, right? B total over square root of 3 VL cosine theta total. You can get IL total. So IL total mean this IL, right? IL total. So IL total is I1 total is IL line current, right? Yeah. So I line total is I1. This is I1 plus I2, then plus I3. Okay. So we can get how many? So we have the total power is 450 over square root of 3, and the line voltage is 430 volts. And we have the power factor total is 0.812. So after that you can get the line current is 667 amperes. Okay. Yeah, this is question A. Any questions so far? Thầy Bá? The others, Bình, Đức Bình. Yeah.
No, teacher. No, teacher.
Okay, so now question B, So question B is we have lead-in. Okay, so we have lead-in. Yeah. So when we calculate Q3, because we have lead-in, so you get the negative value, right? Q3 now is minus 93 kVAR. Okay, and you know, we have the same active power, the same total active power, but for total reactive power, okay, Q1 plus Q2 minus Q3. Okay, so here Q3 is negative, so you get 137.2, and then we calculate the power factor. Equivalent power factor is 0.957. Okay, and then you can get light current. That's a 566. Okay, yeah, we discussed before. If we have lead in, okay, so if we have lead in, we have B3 minus Q3. Okay, what does mean minus Q3 is minus what? Minus 93 kW. So minus 93 kW. Okay, yeah. So we can calculate line loss. Okay, so PLL or delta PLL is 3 IL squared times RL. Do you know RL? Let me see. Okay, so we don't have RL, but you can compare, you know. So if we have all motors are lagging lot, we have power loss is 1 million blah 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 blah. Okay, that means 1.344 times RL kilowatt, and here you get 0.961 RL kilowatt. Okay, so for the second case, that means that's question B. Okay, because synchronous motors operate at lead-in, so we can reduce the power loss. Okay, from 1.344 RL to become 0.961 RL kilowatt. Okay, yeah, this is example 3. Okay, yeah. Okay, it's this one for your reference. So now we come back to V curve. Okay, of course, here, you know, here B is 0, B0. Why? Because you know, if here we have IF, that means I at this point I how many? I 0, right? Here, IF, we have some IF, but I is 0. Okay, so if we have B different from 0, so we get another curve. Yeah, maybe like this. Yeah, like this. And this one is BF is 1. That means power factor is 1. Okay, yeah. So because this is lagging, so they consume Q. That means Q is positive. This is lead-in, so they supply Q. Okay, so that means Q is negative. Okay, or here they say Q consumer. That means the synchronous motor consumes Q. So this one, the synchronous motor rejects Q or inject Q into the power system. Okay, yeah. Here, look, this one is lead-in, right? Lead-in. Why? Because this is II, and this one is V phase. You know, V phase. So II is lead into V phase 90 degree. Okay, yeah. So this is lead-in. So when we have IA1, okay, you can get here AA1, right? So when we increase IA1 to become IA2, so you get more AA2. Okay, and we continue to increase EA3, you get more EA3. Okay, yeah. And we discussed before, right? If IF increase and II increase, II increase, that means EA increase, EA increase. Okay, because IF increase mean the rotor magnetic field increase. So we have EA proportional to K phi M omega, right? Omega, phi M omega. So phi M increase mean EA increase. EA increase here. Okay. And this one for your reference, I also discussed with you about the information. Okay, yeah. I just give you the summary. Okay, now we consider synchronous. Okay, we consider synchronous generator. Yeah, so for a synchronous generator, we have the formula V phase A, right? Minus RA plus JXS times IA. Or you can say we have V phase plus RA plus JXS IA. Okay, yeah. And for synchronous generator, EA okay is always less V phase. So here is V phase. Okay, here is EA, right? Here is the V phase, and here is EA. So EA is always leading to V phase. Okay, yeah. And you know, for this case, this is lagging. This is lagging. So for lagging, the V phase less than EA. Okay, yeah. So you get a P plus JQ. Okay, so here this is leading. So this E V phase, this is EA. Okay, so V phase higher than EA. Okay, so you get B minus JQ. Okay. Now we consider synchronous motor. Synchronous motor, we have two cases. This is under excited, or we can say this is lagging. This is over excited, or we say this is why we know because this is IA here and this is IA here. Okay, yeah. So for this case, look at, okay, for all of them, okay, V phase is always leading EA, right? EA here, V phase here. So V phase leading EA, V phase E leading E phase. Okay, so that means synchronous motors always consume B. Okay, because B flow from V phase right to EA, you know, yeah. And here we have the circuit. Here EA, here is JXS, this one is RA, and this one is the V phase. You know, V phase is always leading EA, so the power flow will be in this direction. Okay, B, yeah, because V phase is leading to EA. Okay, and we know the power flow direction of active power from leading right to lagging. Okay, now we discuss about magnitude. Okay, for this case, look, this is lagging, so the magnitude of EA less than the magnitude of V phase because lagging, so they consume B and they consume Q. Okay, but for this one, you know, look, EA right? Higher than V phase. So Q will be back to the power system because EA higher than V phase. Okay, so the reactive power should flow from EA back to V phase. So that means this motor consume B and reject Q. Okay, yeah, consume B and then apply or supply Q. So you get the B minus Q. It's the motor. Yeah, motor. This one is motor. Motor. So far, any questions? Okay, so if you have no questions, we continue. Yeah, this one for your reference, you can read some slides here at home. Okay, and session 3.3 just for also for your reference. Okay, when you read my lecture, you can understand. Okay, so now we finish. Yeah, finish lecture 3. I think we discuss a little bit this comparison. Okay. Yeah. Yeah. So we compare about generators and motors. Okay. So look, this is generator. Because this is generator, so EA is always leading the V phase. EA here, V phase here, EA here, V phase here. Okay, yeah. So that means they also generate B. They also generate B. Yeah. Now look. So for this case, you know, the magnitude of V phase less than EA. Why? Because this is lagging. Okay, so the reactive power will flow from EA to V phase. So this one you get P plus JQ, or you can say they supply reactive power because this is positive or positive. Okay, so now you know EA, yeah, EA is smaller V phase, so you get a B minus JQ. That means the generator will consume reactive power because it's A less than the V phase. Okay, now motor. For the motor, you know, EA is always lagging to V phase. EA here, V phase here. EA here, V phase here. Okay, so they also consumes B. Consume B. Okay, consume B. Now look. We have here, you know, V phase less than EA, right? As an so the reactive power will flow from EA to V phase. Okay, that means they supply Q. Okay, the synchronous motor will supply or will inject Q. Okay, inject Q. Yeah. So this one should be minus because they supply, right? They supply, yeah. And here, you know, V phase higher than EA. Okay, so the reactive power will flow from V phase to EA. So that means they consume B and they consume Q. Okay, Yeah, so now we have the comparison between generators and motors for supplying reactive power or for consuming reactive power. Okay, and look at these figures. So for this figure, we have some rated parameters. For example, we have this is motors. Okay, so and this is rated power. And I mentioned to you before, the rated power is always output power. So this one you get 21,000 HP. How many RPM? 1,200. Power factor is 1. How about this three phase? So this is line voltage, 6,600. Three phase, the frequency is 60 hertz. Okay, we get 1,404 amperes. Okay, and we have DC voltage. Okay, I mean DC voltage connect to the rotor winding 125 volt, and we have IF rated. IF rated is 2.5 amperes, and the other parameters. Okay, yeah. So now we have the conclusion. You should remember. You should remember. Okay, you should remember some information. For example, if the question 3 give you rated power, so the rated power is always output power. Okay, then this is the key point. So if we have efficiency or we have total power loss, you can get a B in, right? Because efficiency is B out over B in. Okay, and if they give us a three-phase machine, okay, so the voltage must be line voltage, and the current they give us is line current. So it depends on delta connection or Y connection. You can get V phase and I phase. Okay, yeah, please remember the information very important. Okay, now we we do we answer uh, only one um, exercise. Okay, this one I discussed to you before, and of course we have some description here. Okay, we have some description you can understand more. Okay, so we finish lecture 3, and here we have some more information. Okay, you should read it at home. So now we do some exercise. Maybe I just pick up one. Okay, one questions and answer to use, and the others this is for your homework. Okay, so maybe I will choose which questions. Mm, which one? Which one is good? Okay, so for maybe I will choose okay, maybe I choose mhm, synchronous motor, right? Synchronous motor. So uh, okay, just questions 8. Okay, 8. So now I will answer to use homework and question 8. Okay, so we need to summarize. Can you hear me clearly, Ba? Okay, so now we do this exercise. So we have synchronous motor, right? Synchronous motor Y connection, three-phase. Okay, so here we have three-phase synchronous motors Y connection. Okay, what else? They give us 60 hertz and 440 volt. So okay, so we have F A 60 hertz. Because this one is three phase, so the voltage is always line voltage, and line voltage is 400, right? 440 volt. Okay, yeah. What else? This synchronous motor has a synchronous reactance of 1.5 ohm. So we have XS. XS is 1.5 ohm. What else? The field current has been adjusted so that the torque angle is 25 degrees when the power supply by the generator is 90 kilowatt. Okay, so we don't know IF, right? We don't know IF, but we know the torque angle is 25 degrees. 25 degrees. Okay, when the power supply by the generator is 90 kilowatt. Okay, so that means we have a P in, right? We have P in. Yeah, the power supply. So that means we have P in. P in how many? Yeah, P in. Yeah, look, when the power supply by the generator is 90 kilowatt. 90 kilowatt. Okay, so this is synchronous motor. So of course, B out, E, B rated, but we don't know. We don't know, but we know B in 90 kilowatt at the phase angle deltas of 25 degree with some value of IF. Okay, so the question is, what is the magnitude of the internal generated voltage AA in this machine? Okay, so they ask us to calculate magnitude AA. How many? Okay, yeah. Of course, we know AAE, the magnitude with the phase angle deltas, right? Because V phase E, the magnitude of V phase with the phase angle 0, and this is Y connection, right? This is Y connection. This is Y connection, and they give us V line, so we can calculate V phase. Okay, so we have V phase E, V line over square root of 3 because this is Y connection, right? So we can get 440 over, right, over square root of 3. Yeah, and then you can get answers. 440 over square root of 3, so we can get 254 volt, right? Right? 440 over square root of 3, get 254. Okay, so now we can get the V phase A 254 with 0 degree 1. Okay, yeah. So we would like to calculate this one. So we have the formula B in A3 V phase AA, right? Sine delta over what? Over XS, right? So we can get AA is how many? B in times XS. B in how many? 90, right? 90 kilowatt. So that means 90,000 watts. Time XS is 1.5 over what? Over 3 V phase A to what? To 254, 254, 254. Yeah. And what else? Divided by sine theta. So we have series sine delta. So delta is 25. So sine 25 is 0.4226. So here is 0.4226. Okay. Yeah. Double check. This is 90,000 times 1.5 over 3. AIE. We find 2554. And then, yeah, okay, correct. And then you can get EA 90 times 1.5 divided by 3 divided by 254 and 0.4226. So we can get 1419.234. Okay. Yes. Yes. Okay. Yes. Yes. Double check, please help me to double check. 90,000 times 1.5 over 3 over V phase 254 and over psi 25. Yes, we get 114. Okay, yeah, so this is EA. This is EA. So now you can draw the phasor diagram, right? Yeah, you can draw the phasor diagram. So here, this is V phase equal to 254 with 0 degree. Okay, we know EA. We know EA with the 25 degree. Okay, so this one is synchronous motors and lagging. So IA somewhere here. Okay, so IA should be at the bottom. Okay, so we can get EA. So for example, here is 25 degree. Here is here 25 degree. So this is EA. Okay, then you can get here here E. There's something wrong. So for this win somewhere here, and you know the magnitude of IA larger than V phase because this one is 419 and this one is 254. Okay, so that means this one should be leading, not lagging, and this is leading. Yeah, this is leading. Yeah, this is leading. Okay. Yeah. So if we have leading, so I should be somewhere here. Okay. Somewhere here. So for example, oh, this is 25. So this may be higher than 25. The ratio of yeah, maybe 25. Okay. Yes. So 25 degrees, maybe here. Yes, here. Okay. Yep. And for example, here is A, right? A. So maybe yes, maybe I try again. No, not good. Not good. Okay. So this is EA. This is EA. Okay. Then this one is JXSIA. Okay, so yes, so here is EA, II, here II, okay, here is EA, and here is V face. Okay, so now this one is EA, this one is V face. Okay, yeah, and this one is liquid, not liquid. Any question, please? Ba, any questions? Okay, so now continue. What is the magnitude? So finish. Okay, internal generator. What is AI? Yeah, yeah. So now we have finally we have AI E1419.23 with the phase angle plus 25 degrees. Okay, minus 25 degrees. Okay. Minus 25 degrees because AI here, 25 degrees. So if we come back to the theory, this is the same, look, for synchronous motor, and then if IA is leading, so EA higher than V phase. EA is higher than the V phase. Okay, so that is correct. Then continue. What is the magnitude and the angles of the armature current? What is the motor's power factors? Okay, that means the question B. Question B, they require to calculate IA. That means how many magnitude of IA and the phase angle theta. Okay, of course we know theta is leading, right? This is leading. Yes, and power factor does mean cosine theta. So how can we do? Okay, so we have the voltage equation, right? We have the voltage equation. We have what? We have V phase is EA plus RA plus JXS times IA. Okay, but we don't know RA or RA is 0, so we skip this one. Yeah, we can get the V phase E is EA. Okay, plus JXSIA. Okay, so we know V phase, we know EA, so we can get IA, right? So IA over dot is V phase minus EA over JXS, and V phase is how many? 254. Okay, we have 254 with 0 degree minus EA. EA is 1419.23 with the phase angles minus 25 degree. Okay, then over J2, how about XS 1.5. Okay, so here you get 1.5. Okay, you get the answers. So we have 254 with 0 degree minus 419.23 with the phase angle minus 25. Okay, and divided by 1.5 J Yes, so we can get 149 with the phase angle 145, right? 144.9, that is 145 with the phase angle 35.4 degree amperes. Okay, yeah. So now we conclude that the theta is plus 35.4 degree. This is leading. Okay, so this is coincide with the theory we get before. Okay, this is leading. This is leading. Okay, yeah, yeah. So we can calculate power factors. So we have cosine 35.4. Okay, so you get the power factor is 0.815. Okay, leading. Okay, so now you get this one is 30 what? 35.4. 35.4, and this one is 145 with 35.4 degree. Okay, so this is delta, this is theta. So we can get Riemann. Okay, so now we have the phase angle. Delta is 25 degree, theta is 35.4 degree. So you get Riemann. Riemann is the phase angle between IA and EA. That means this angle plus this angle. Okay, so we can guess how many? 60.4 degree. Okay, this is the phase angle between IA and EA. Okay, any questions? Any questions? Triệu Thanh Dũng. You hear me? Hữu Nghĩa, Đỗ Nguyên Khôi.
I got no question. I'm fine.
Okay, so continue. Now, so question C. If the field current remain constant, what is the absolute maximum power this motor could supply? Okay. Now we assume question C. Now we assume IF is constant, right? IF is constant. That means EA constant, right? IF constant, and IF constant means phi m constant. Phi m constant means EA constant. EA is constant. Okay, EA constant. What is the absolute maximum power this motor could supply? So we have the formula, right? We have B in E 3 sorry, V phi EA sine delta over XS. So you get a B in max if delta is 90 degree. Okay, delta 90 degree. So you can get 3 times V phi is 2 what? 254, and then AAE 419. Okay, 254 and 419 over XS is 1.5. You get how many? 3 times 254 times 419. Okay, divided by 1.5. So you get 212,852. That means nearly 1213 kilowatt. Sorry. 3 times 254 times 419 divided by 1.5. Okay, yeah, so correct. So we have the rated, you know, we have the, yeah, we have B in Okay, this one is not rated. This one is not rated. Okay, they haven't give us the information about the rated power, but we know. Okay, the maximum, and the maximum input powers will be 213. Okay, yeah, so we can answer the question here. Okay, so we also draw the waveform. Okay, this AP in. Okay, and this one is delta, right? Delta. So we can get, because this is sinusoidal waveform, so you get the yeah, so you get the curve of P in like this. Okay, like this. So this is 0 degree, this is 180 degree, and this one is 90 degree. Then you can get the P in max. Okay, P in max. And you know here we get the delta E 25 degree. Okay, so this is 90, so 25 degree somewhere here. Okay, so if we have 25 degree, right, you can get the B in how many? 90 kilowatt. Okay, yeah, look, if we have 25 degree, right, B in the 90 kilowatt. Okay, yeah, so like this. Okay, yeah, here, here, and B max how many? 213 kilowatt. Okay, yeah, so I guess some rated power somewhere here. Okay, this is rated power. Okay, yeah, and this is delta. Yes. So we also calculate Q max. Q max. Okay, Q max how many? So if delta is 90 degree, yeah, you can get a B max, right? B max. So, and we also get EA now is the magnitude of EA with the phase angle 90 degree, because at the 90 degree you get the B max. Okay, and now you can get EA how many? EA you get 1419.23 with 90 degree. Okay, 90 degree. So we can calculate back. IA. Okay, so now okay, now we have V phase EA plus JXSIA. Okay, so now in this case, you know, at 90 degree you get a B max, so we need to calculate phi max how many. So B max if delta in 90 degree, so here 90 degree, so you get this one. Okay, so now we come back to calculate IA, right? IA. So now we have IA is V phase minus AA. Okay, okay, divided by JXS. Okay, so V phase how many? 254 with 0 degree, and now we have EAE 419.23 with 90 degree. 90 degree. Okay, yeah, and then we divide this by JXS, so we can get IA. Okay, we can get IA. So that means if here we have V phase, right, 254 with 0 degree, how about EA? So EA like this. EA like this. Why? Because we have delta in 90 degree. Okay, 90 degree. Yes. Okay. Maybe here should be longer. Should be longer because EA. Yeah, this should be longer. EA. So EA here, 419 with 90 degree minus 90 degree. Okay. So you can calculate this one. How many? So JXS mean 1.5. 1.5. So you can get the answers. Okay, 254 with 0 minus 149 point 83 with 90 degree. Okay, and then divided by 1.5 J. Yes. Okay, we can get 326.7 with minus 148 degree. Okay, yeah. So that means IA somewhere here. Okay, so IA somewhere here because this one is minus 148 degree. Okay, yeah.
Teacher, is minus 90 degree.
How many?
The angle should be minus 31.2 degree.
Oh, this one?
Yes.
Why? Because this one is minus, right?
Yes, it's minus 90.
Minus. Sorry. Yeah, my mistake. So here you get how many? 3 to 6, right?
Minus 31.
How many? Minus. How many?
Minus 31. Oh, the amplitude is 3 to 6.
6 with?
Minus 31.
Minus 31 degree. Okay. Yeah. So I have problem here. Yeah, my step is okay. So get deleted. Okay. So here we have EA. Yes. And here we have IA. Right. Yes. Okay. We have IA here. With the 3 to 6 with the minus 31 degree. Okay, yeah. So you can get right. Yeah, so you can get this one. Yes. So we can get you can get the EA. Okay, so we can get here a JXS IA. Okay, yeah. Okay, so now we have more Q, right? More Q. Yes, we have because this one is proportional to Q, so more Q. Okay, so how can we calculate Q? Okay, this one is lacking. So we can get the Q is square root of 3 square root of 3 VL, right? IL psi theta, or you can get 3 V phase IA psi theta. Okay, so you get 3 V phase harmony 2 by 4, IA harmony 3, 2, 6. Okay, and psi 31. Psi 31 degree. Okay, yeah, psi 31 degree. Yeah, and you get how many? 3 times 254 times 326 times psi 31. 31. So you get 127941 var, or you get 127 kvar. Kvar. So this one is Qmax. Qmax. Okay. Yeah. Okay. Yeah. Qmax. So that means for these synchronous motors, they can consume Bmax and Qmax, right? Yeah. So Bmax you get 213, and Qmax you get 127J. This is kVA. kVA. Yes. Okay. Yeah. Yeah, so remember that. Okay, this one for lagging. This one is for lagging. This one is for lagging. So the synchronous motor consume consume to B. Okay, and yeah, they will supply Q. So for here, sorry, so here should be a minus. Here should be minus. Here should be minus because they supply Q, not consume. Okay, so this one you get a minus. Okay, yes. Why? Because the magnitude of AI, higher than the magnitude of V phase. So that means this synchronous motor will supply reactive power. Okay. So finish. We take a break, and then after 15 minutes we go to the new lecture 4. Okay.